Hello everyone, I'm Suraj from Sri Venkateswara College of Engineering. Today I'll be covering a topic called deep learning in the field of dentistry, which comes under the subject deep learning. So the topics that are covered in this presentation are: first we'll see the introduction, then we'll be seeing the materials and methods. After that we'll be coming to the results, and then some discussions about the research paper, and then we'll finally reach to the conclusion. Yeah, so we'll come to the introduction first. It is essential to emphasize that the damage caused by cavities is irreversible and can be result in tooth loss if not promptly addressed. Hence, early detection and treatment of dental caries are paramount to prevent irreversible harm and ensure optimal oral health. Furthermore, the patient that with dental caries or other oral diseases, the primary objective of a dentist is to determine the severity of condition as quickly as possible and select the most appropriate treatment option based on the patient's individual needs. Early intervention is essential to minimize patients' discomfort and prevent further damage to oral health. Although the severity of these diseases can vary, medical imaging techniques can provide dentists with a clear and accurate picture of the patient's oral health status. In contrast, X-rays are used for single teeth or localized examinations, and CT is used for panoramic examination to capture the more information. By observing the medical images of the tooth, the doctor can see the distance between roots and the nerve, whether the tooth extraction is risky, whether the root canal treatment is done correctly, etc. In addition to traditional medical imaging techniques such as CT and X-rays, cameras, time imaging of surfaces and tissues, these non-invasive techniques enable dentists to identify early signs of dental problems and monitor the effectiveness of intervention over time. These photos provide close-up views specific areas within the oral cavity, capturing detailed information about the condition of the teeth. So the AI in dentistry has evolved from the weak AI, which solves specific problems, to more advanced applications like deep learning. The neural networks, particularly CNNs, that is convolution neural networks, are central to AI's application in dentistry, especially for processing complex images. Deep learning's diagnostic accuracy in medicine, including dental radiology, is approaching human expertise. So the rise of the self-learning algorithms and improvements in the computational power, they have significantly contributed to AI advancements. The review highlights that the increasing role of AI in the dental diagnostics, focusing on the main maxillofacial radiology. Deep learning is transforming the assisted diagnosis from a secondary opinion tool into a very uh, very ongoing technology now. Next, we'll be seeing the materials and methods. So, the systematic review of studies applying deep learning in dentistry was conducted using database like PubMed and Scopus. Articles were selected based on their focus on deep learning in dental diagnosis, classification and segmentation also. So the studies using multi-layer perceptrons were excluded due to their limited learning capacity. The review aimed to analyze factors such as network architecture, training data size, evaluation results and imaging modalities. So the selected studies focused on various dental imaging methods, including 2D radiographs and 3D cone beam computed tomography (CBCT). After conducting all the experiments and all, so the results that are obtained from the dentistry was more studies use CNN as the primary network architecture for dental imaging tasks, with an increasing trend of applying pre-trained networks like AlexNet and VGG. The size of training datasets varied, ranging from 100 to over 1000 units, with studies generally showing good performance. The applications of deep learning extended beyond teeth, covering gingiva, periodontium, and osteoporosis and other anatomical landmarks. While most research used traditional imaging methods like 2D X-rays, some explored newer technologies like optical coherence tomography (OCT). Despite promising results, dataset size and image quality remain challenges for achieving clinically relevant accuracy. So coming to some of the discussions that were carried on from this research paper are: deep learning has improved diagnostic tools in dentistry with applications extending across various imaging modalities. However, challenges include the lack of standardized public datasets, reliance on small datasets, and issues with image quality, particularly in CBCT. Future efforts should focus on creating public dental datasets and standardizing data collection protocols. While AI has shown potential in dental diagnostics, it needs to achieve higher accuracy, with some of studies still below the clinically expected. It's almost 98 to 99% accuracy threshold. Additionally, AI systems need to move beyond the black box model to allow greater transparency and reliability in diagnostic recommendations. So finally, we come to the conclusion that AI, especially deep learning, is transforming the field of dentistry, with CNN playing a critical role in image classification and diagnosis. Despite the progress, there are still hurdles that are related to data availability, standardization, and accuracy. The development of larger public datasets and international standards for dental images, particularly CBCT, is necessary to fully realize AI's potential in dental diagnostic. In future, AI algorithms must become more transparent, that will be enabling clinicians to understand and trust AI's decision making process. With these advancements, AI is playing an increasingly important role in dental practice. So thank you everyone. I hope you understood the concept that are covered in this presentation and learned great. Thank you.